our goal. So our goal for Moneyball is to leverage data-driven strategies to identify undervalued players and optimize team performance efficiently. And we use this by AI, which enhances the goal by providing advanced predictive analytics and real-time decision-making tools, making player evaluation and game strategy better. And what even is Moneyball? So Moneyball is based on a true story that follows Billy Beane, the general manager of the Oakland A's, who uses statistics to build their team better and uses by sabermetrics to focus on undervalued players and competitive advantage. And after he did this, the A's got a 20-game win streak in 2002, and this impacted like all sports to use statistics overall.
This is notebook one. So the baseball vocabulary is at bat, hit, run. At bat is the number of times a batter comes up to bat. A hit is the number of times a batter safely reaches base by hitting the ball in fair territory. A run is the number of times a player successfully advances around all 4 bases to score a point for their team. What does each row in this table represent? It represents the team's stats and how well they did each year. Slugging percentage represents the total number of bases a player records for that. When we made the column tables, it allowed us to look at the slugging percentage by multiplying all the runs based off their score. On-base percentage measures a player's overall ability to reach base and contribute to their team's offense.
This is a graph of the winning percentage. So we have 3 graphs here: batting average, slugging percentage, and on-base percentage. See as all the ones in the x-axis increase, the winning percentage also increases. This indicates a positive trend. This is a correlation heat map. So here the features are plotted against themselves. So the numbers with 1 or red colored like squares, they're like super correlated, and the ones with like the white background, they have no correlation at all, and the ones in the blue have a negative correlation. And this is Z-score. So batting average, slugging percentage, and on-base percentage can't directly be compared in a linear regression model because of the units and scale. So in order to compare them, we calculate the Z-score. So the formula is up there, and the U refers to the mean or average, the O refers to the standard deviation, which is how the data is spread out. And here is a graph of all 3 plotted on top of each other.
On notebook number 2. So adding in seniority. So basically, we added abrogation eligibility, which means the player has played more than 3 years but less than 6 years. So, and we also added free agents, which means the player has played more than 6 years. And this helps us to negotiate with teams how much price the salary should be. Logarithmic scaling. To better predict players' salaries, we use a technique called logarithmic scaling. This involves we adding a new column called log salary, where we apply logarithms to each player's salaries. This reveals clear salary patterns. By transforming the data, we can enhance our model's accuracy in predicting salaries, as you can see in the graph over there. Feature affordances according to the decision tree. Feature affordances are important because we can see all the features in that graph, like seasons played, games, batting average. The higher the seasons played, the higher the salary is. Like more batting average, the more higher the salary. So based on the features, shows which one's more important, and that will impact the salary.
Notebook number 3. So we worked on a lot of cluster analysis in this notebook. So cluster analysis is a fundamental technique in data science that is used to uncover natural groups in the data set. And then here are some examples of where it can be used: data exploration, feature engineering, and anomaly detection. One hot encoding. So each player on the field has a position, and the computer cannot take strings into account, so we convert them into binary or true and false, so the code is understandable to the computer. And these two pieces of code, we normalize and standardize the data. And in the bottom part, we merge the 3 data sets, batting, pitching, and fielding, into one data set that we can use to view all everything. And this is a graph of k nearest neighbors. So KNN stores training data and is used for classification and data clustering. And then K is the parameter asking how many nearest neighbors you want. So in this graph, the K is 5, and the red dot represents the chosen player, and the blue dots represent the nearest neighbors and the rest of the other players. And we can see the on-base percentage and the batting average have a positive correlation.
So here are future directions. So our future directions allow us to see who to draft for the upcoming season, how location can impact the team, and what workouts will help the team